Hey guys, welcome back to Learn Python the Hard Way. Today we're going to focus on exercise 23, strings, bytes, and character encodings. So this is a new exercise about reading more complex code. And as always, you can find the link to the current exercise in the description below. This is part of the paid section of the book, so you would either need to purchase the book, Learn Python the Hard Way, or alternatively, of course, feel free to just follow along with the video. So in order to get started with this exercise, we first of all need to download a text file called languages.txt, which is the following file here, which contains a bunch of different text entries. So that's the first step. I already downloaded it and moved it into the appropriate folder that we're working out of. So this file here that we downloaded actually creates a list of human languages that demonstrate a couple of different concepts. So first of all, how modern computers store human languages for display and processing, and how Python 3 calls the strings. We will also learn how we must encode and decode Python strings into a type called bytes, and how to handle errors in our strings and byte handling. And the overall purpose, of course, is to better understand how to read code and find out what it means, even if we've never seen it before, and even if we encounter some new concepts. So in addition to the different concepts and functions that we already know, we will encounter some new concepts, for example, if statements and lists, which we will cover in a lot more detail in later exercises. But for right now, we will just see that and don't need to understand it in depth. So, and just as a warning, this exercise is quite hard, so it may take a little time to get familiar with it and to actually understand it properly. So to get started, let's type out this code here, and we are going to open the terminal. And I'm using Visual Studio Code, so I'm going to type out code and then the name of the new Python file that we want to create, so exercise 23.py for Python. And to get started, we can type out import sys to import a new module sys, and then afterwards we are going to store a number of different variables. And what we store in there is actually what we get from argv, from the command line argument. And here we see a different way of how we can access argv. Instead of saying from sys import argv, we can also just import the entire module sys. Then we need to make sure that in order to access argv and any other components within the module, that we actually type out sys dot and then the respective module. So for example, sys.argv. Let's first of all define a main function, which takes a language file, encoding and errors. And we are going to read the content of the language file line by line and store it in the line variable. And if the line variable has some content, then we're going to call printLine, passing in the line, the encoding, and the errors. And we're also going to return main, entering in the language file, encoding, and errors. And to properly do that, we need to still define printLine, which we call here. So we're going to define that as a new function, which also takes a line, encoding, and errors as arguments. We define a new variable next lang. And on line, which is one of the arguments here, we call then strip at the end of it, which is going to remove any white spaces from the end. Next, we define a new variable raw bytes, and we take next lang and encode it. And what that means, we will cover that in a bit. Taking encoding and arrows, which we set equal to arrows. And we define a new variable cooked string, which is equal to raw bytes dot decode, which takes the encoding and also arrows as an argument here. And then finally within this function we're going to print out raw bytes, so the variable we defined here, and then a string followed by cooked string, which is the second variable we defined here. Then we open actually our text file languages.txt, which we downloaded, and we also pass encoding to it called UTF-8, and we store all of that in languages in a new variable. And finally we call our main function that we defined up here, and we pass in languages, which is a variable here, which again is basically the content of the languages text file, which we opened with a certain encoding, UTF-8. We also pass in the input encoding and the arrow. Alright, let's save this. And before we take a closer look at what the different lines actually do, let's first of all go ahead and open our terminal again. And now we can run our code file by providing the Python number followed by the script name, which of course corresponds to the command line arguments here. So the first one is the script. Then we pass in the input encoding and then the arrow. So here we pass in UTF-8 as the input encoding, and we want to have a strict error handling. Let's press enter, and this is the output that we get here. And that also matches the output here in the example exercise. And what this actually does is, this example uses UTF-8, UTF-16 and BIG5 encodings to demonstrate the conversion and the types of errors that we can get. And all of that is called a codec in Python 3, but we use the parameter encoding in its place. And at the end of the exercise, there's a list of additional encodings if you want to try additional codings there. All right, so let's take a look actually at the output that we get here. So if we compare that to the text file that we had, and if we go back up here by a little bit, then we can see we have Afrikaans here. The beginning, this is the first string inside of our text file, the first line basically, and that would be the raw bytes here. If we encode it and then if we decode it, it actually shows this. And we can see that for some of the other languages here, we actually have the encoded part here, and then what it actually represents, because in itself the different characters that we use, they need to be represented of course in the computer, and to do that, especially if these are special characters, we can encode them in a certain way so the computer can actually read that, and then we can switch between decoding and encoding to properly display this here. And in order to properly understand that, let's first of all learn some about the background information here. So we need to first of all learn some basic about how data is stored in a computer. So in its simplest principle, actually we store data in zeros or ones that the computer can read, which basically represents, or can be represented as a switch that's either turned on or off if there's electricity or if there's no electricity. And those zeros and ones are generally referred to as bits. Now, if a computer could only work with 1 and 0, that would be quite inefficient and annoying. And therefore, computers take these 1s and 0s and use them to encode larger numbers. So, for example, a computer may use 8 of these 0s and 1s to encode 256 numbers, 0 to 255, which is basically 1 byte, so 8 bits. And that means that we have a representation of basically 8 digits, which can either be 0 or 1. So for example, if we have here a total of 8 zeros, that would represent a 0, which is a lower bound here of our range of characters. And if we have all 1s, so 8 1s, that would be 255, which would be the upper bound. And then of course we can have a combination of both. For example, if we have 4 zeros and 4 1s, that would be the number 15. And again, a sequence of 8 bits of 1s and 0s, as we have here, for example, that would be a byte that we store. And previously, everyone had their own convention of what a byte is. For example, 9 bits, 7 bits, or 6 bits. But this has been standardized to be 8 bits. And in order to represent characters with those bits, there is a standard way of representing that, which is the American Standard Code for Information Interchange, or ASCII. And that basically maps the different digits, so 0s and 1s, to different characters, to different letters, for example. And based on that, for example, the number 90 represent capital Z, which in bits is this here, 10111010, which gets then mapped by the computer inside of what's called an ASCII table. So if you want to take a look at that, we could open the Python idle by typing out Python 3. And now we can, for example, type out exactly that sequence of bits, of 0s and 1s, after OB. So OB 1011010. I'm sorry, that is 0B10111010, and that would be 90. Or we can go ahead and type ORD and then pass in capital Z, which is 90. And we can also basically do the reverse and say we want to turn that number 90 into a character, which would return Z. So first here, what we did up here is we write the number 90 in binary, which is this here. Then we get the number based on the letter Z. And then finally, we convert the number 90 here back to a letter, which gives us Z. But we don't really have to worry about that in detail. It's just to show that basically each letter can be represented by a sequence of 1s and 0s. And that's basically how strings work. So strings are just basically a sequence of different individual characters. So if we take, for example, the name that A. Shaw, then that is a sequence of bytes that are 90, 101, and so on and so forth. So we saw before that 90 is equal to Z, so the first letter here. And then, of course, we follow that with a sequence of the other different letters in that name. And that is basically how we can convert individual characters as a sequence and how we can turn that into a string. But the problem with ASCII is that it only encodes English and maybe a few other similar languages. It doesn't support any special characters. The reason is that a byte can hold 256 numbers, so 0 to 255, or the same represented here in binary. But it turns out there are a lot more characters than 256 throughout the different world's languages. So if we just think about, for example, Chinese, I mean, there are thousands of characters, so of course they cannot be stored into such a small number. And in order to solve that, there was a separate concept developed called Unicode. and that's basically a universal encoding for all human languages. So the solution that Unicode provides is like the ASCII table, but it's much bigger by comparison. So we can use 32 bits to encode a Unicode character, and that is more characters than we could possibly find. So 32-bit number, that means we can store a total of 4,249,967,295 characters, so 2 to the power of 32. So that's more than sufficient for every character in a possible human language. So it would cover everything that we are looking at. So 32 bits is 4 bytes, because it's basically 32 divided by 8, because 8 bits are 1 byte. So that means there's a lot of wasted space in most text we want to encode, because we don't need the total of 32 bits to work with for most languages, for example, for writing some text in English. So instead we can also use 16 bits, 2 bytes, but that may still lead to some wasted space. So the solution here is to use a clever convention to encode most common characters using 8 bits and then escape into larger numbers when we need to encode more characters. So that means we have one more convention that is nothing more than a compression encoding, making it possible for most common characters to use 8 bits, then escape out into 16 or 32 bits as needed. And that's called UTF-8, which means Unicode Transformation Format 8 bits. So that's a convention for encoding Unicode characters into sequences of bytes, which are sequences of bits, which turn sequences of switches on and off. So it's a combination of ones and zeros, basically. So we can use other conventions, other encodings, but UTF-8 is the current standard that's being used. So now with that being clear, we can now look at the output of the commands above. So if we just switch back here and run the file again, this is the output that we get here. So the exercise 23.py script is taking bytes written inside the B and then string, so byte string, and converting them to the UTF-8 or other encoding you specified. On the left is the number for each byte of the UTF-8, shown in hexadecimal. So for example here, that would be that value in hexadecimal that we specified. And at the right, there's a character output as an actual UTF-8. So what it actually represents then in written language. So the way to think of it is that the left side of this arrow here, this one here, is the Python numerical bytes or the raw bytes Python uses to store the string, and we specified that with B quotation mark to let tell Python this is bytes. And these raw bytes are then displayed cooked on the right side, so we can see the real characters in our terminal. And that's of course what we accomplished here by this cooked string, which we then also printed out here, and we called raw bytes decode to actually decode that from that hexadecimal representation to the actual Unicode string. So now we have an understanding of strings and byte sequences. So in Python, a string is a UTF-8 encoded sequence of characters for displaying or working with text. The bytes are then the raw sequence of bytes that Python uses to store this UTF-8 string and start with a B quotation mark to tell Python you're working with raw bytes. This is all based on conventions for how Python wants to work with text. So here's a Python session showing the author encoding strings and decoding bytes. So here, for example, we can see that if we just hop back into our idle, we can have here raw bytes as a variable, and we can pass in a hexadecimal representation. And let's just briefly copy that over. Then we have a UTF string and set it equal to these characters. And now we can go ahead and say we want to decode the raw bytes that we defined up here. And this gives us exactly those characters here back. And we can also go the other way around. So we can say UTF string, which is this character here, and call encode instead of decode on it. And this is going to give us back this hexadecimal representation that we also have up here. Just to make sure that this is actually the same, we can say, or we can check if raw bytes are equal to UTF-8 string, so these characters here, encoded. And that gives us back true because that's the same. And we can also go the other way around and say, is UTF string, so this character here, is that the same as taking the raw bytes up here and actually decoding that? And that's true as well. So that's how we can basically see how we can turn the hexadecimal representation into those actual UTF strings, UTF characters, and the other way around by using encoding and decoding. And all we need to remember is that we have raw bytes represented in hexadecimal, and if we have that, then we must use decode to get the actual string. And raw bytes have no convention to them, they're just a sequence of bytes with no meaning other than numbers, so we must tell Python to actually decode this into a UTF string. Instead, if we have a string already, like we have here, and we want to send it, store it, share it, or do some other operation, then usually it will work, but sometimes Python will throw an error and say it doesn't know how to encode it. And here again, Python knows its internal convention, but has no idea what convention you need. In this case, you must use encode to get the bytes you need. So that's how we use decode and encode. And the way to remember this, even though of course we can still look it up most of the time, is to remember the mnemonic DBES, which stands for decode bytes encode strings. So DBs, if you say that in your head, then you know that if you convert bytes and strings, that when you have bytes, you need a string, so decode bytes, and when you have a string and need bytes, you would encode strings. So with that in mind, let's take another look at our actual code here. So in lines 1 and 2, what we do here is we start with our usual command line argument handling, so that we import the module here, and then we take the command line argument and store it in those 3 different variables. Then after that, we define the main method here, and this will be called at the end of the script to actually get our script started. So the first thing our function actually does is to read one line from the language file that has been provided using readline, and that would be stored in the line variable. Now we learn a new concept here, and we'll cover that later on, but we are using an if statement. And that lets us generally make a decision in our Python code. We can test the truth of a variable and based on that truth run a piece of code or not run it. In this case, we are testing whether line has something in it here using if line. So the readline function that we call up here will return an empty string when it reaches the end of the file, and then if line simply tests for an empty string. And as long as readline returns actually a value, then if line will be true, and the code underneath is then executed. And if it's not true, so if the file is actually empty, then we're just going to ignore that code and just continue with the next lines. Right, but if there's actually some code here, it will call printline, which is defined down here in a separate function. That simplifies the code, so we don't have to put this in here, but we can separate it out and have it in a separate section here. So that means we can basically just focus on the code in main, and we basically encapsulate whatever should happen with printline and put it into its own function. So and then we are going to return main. That looks like we're calling the function inside itself, which seems like it should be legal to do, but it's actually not. So we can do that. We can call main inside of the function itself. So here we would return main, and we would basically just loop over that and call the function over and over again. And the if statement here keeps the function actually from running forever. So we would basically, as long as there's a line here in our file, we basically return to main, and we would read the next line. And that goes on. So we call main over and over again until we reach the end of the file. And then of course the line will be empty, and therefore this will no longer be executed and the main function basically ends. So this way we can make sure we actually go through the entire file and then stop ultimately when we reach the very end of the file. And that's a concept we are also going to use in the future, called recursion. So after that we define actually the print line function, which does the actual encoding for each line from the language's text file. So here, first of all, what we're going to do is for each line, we're going to strip any ending characters, so \n, so new lines from the line string. And then afterwards, we take what we receive from languages.txt and encode it into raw bytes, and we store that in the raw bytes variable. So we are using the encode method here, the encode function, to actually achieve that. And then we do the exact opposite here with the cooked string variable, and we take the raw bytes that we have here and we call decodes on it. So this string should be the same as the next lang variable. So then we simply print out both of that, the raw bytes and the cooked string here, the encoded and decoded part. And once we are done with that, we are going to open the languages.txt file. And at the very end here, we simply run the main function that we defined up here with all the correct parameters to get everything going and kickstart the loop. And again, the if line statement here prevents our loop from going on forever. All right, so that's basically how our code works. And now let's do a little deep dive into encodings. So we can now use our little script to explore other encodings. Here's the author playing with different encodings and seeing how to break them. So instead of running UTF-8, which we used before, we can, for example, go ahead and run UTF-16 and display the output here. Or as an alternative, we can, for example, go ahead and run big 5 on this. And then we're going to run into some errors here, because then the encoding and decoding doesn't properly work anymore. So here, just to summarize, he's first of all doing an UTF-16 encoding to see how that changes compared to UTF-8. And we can also use, instead of UTF-16, we can also use UTF-32 as an alternative option. After that, we try big 5, which was this here. And we see that Python does not like that at all, so it throws an error that big 6 can't encode some of the characters at position 0. One solution is to tell Python to replace any bad characters for the big 5 encoding. So we can see that it doesn't work with all the available encodings, that if we pass some of it to it, then it will actually run into some errors. And these are some of the examples of how we can actually break the code. So if we pass some invalid encodings to this particular command, then it will throw an error. But again, if we go back to UTF-8, then it will properly encode and decode the file. So that's it for exercise 23, how to encode and decode files. And I'll see you guys next time with exercise 24.